Avi Loeb explains that if an artificial interstellar object visits the solar system, the implications would be enormous.
So are they lying? Are they misinterpreting the data?
It's wishful thinking.
He suggests these objects could release probes to visit nearby planets. In recent statements, Loeb confirmed the possibility that mini probes could be accompanying 3I Atlas.
Actually visiting planets or going near them, it actually releases probes.
NASA is on alert. 3I Atlas has been behaving strangely. Multiple objects are traveling with this interstellar comet. Scientists don't really know why. Right now, an object from another star system is racing through our solar system at over 100,000 miles per hour. And it's not alone. Scientists detected something never seen before around an interstellar visitor. Multiple distinct objects of light in proximity to the main body. Gemini Observatory, North, captured images showing several companion objects with timing so precise that amateur astronomers across 3 continents independently confirmed the same findings within 72 hours. Spectroscopic analysis from the Very Large Telescope in Chile reveals 3I Atlas contains virtually no dicarbon, the molecule that makes comets glow green. Yet ground-based photographs clearly show a green hue developing around the object. Astrophysicist Avi Loeb attributes a significant probability that this might be hollow or composed of material we don't have on Earth. Even more disturbing, at the 3-second mark of time-lapse footage, a brief green flash appears. Not a camera artifact. A diffused glow that shouldn't exist. 3I Atlas broke every rule we thought governed interstellar comets. Here's what should terrify you most. An object traveling at those speeds, if hollow, should have been torn apart by now. Thermal stress, gravitational forces, rotational pressure. It survived a direct coronal mass ejection hit in early October. It's still intact, and now multiple objects are appearing around it. Think about that. Before we dive deeper into this cosmic mystery, if you want to stay updated on what might be the most important discovery in interstellar astronomy, make sure you hit that subscribe button and turn on notifications. Because what we're about to reveal will challenge everything we know about objects traveling between star systems. And drop a comment telling us, do you think these are natural fragments or something else entirely? Let's talk about the objects themselves. 4 distinct designations have been identified traveling in the same region. C2022 A6 Lemon, C2022 R2 Swan, C2022 K1 Atlas, and the primary interstellar object, 3I Atlas. Skywatcher Tobazil on X analyzed the latest Gemini Observatory images, and the objects around 3I are clearly visible. Distinct points of light, not artifacts, not background stars. Objects moving with the comet. When amateur astronomer Stefan Burns posted his time-lapse animation earlier this month, other astronomers immediately began their own analysis. A German observer called Night Monkey identified multiple fast-moving points of light in the images. Another researcher, Alexander Flum, pointed out something specific at the 3-second mark, a brief green flash, diffused but distinct. Here's the problem. That green glow shouldn't exist. Spectroscopic data from Chile's Very Large Telescope showed 3I Atlas is carbon chain depleted. It contains virtually no dicarbon. Dicarbon is the molecule that causes comets to glow green when energized by solar ultraviolet radiation. Without dicarbon, there should be no green glow. Zero. Yet multiple ground-based photographs from early September clearly show green coloration developing around the object. The data contradicts what we're seeing with our own eyes. This connects directly to Avi Loeb's recent calculations about 3I Atlas's trajectory and behavior. Based on the object's movement patterns, Loeb suggested it might be hollow or made of extremely light material unknown on Earth. Let that sink in. If 3I Atlas is hollow or composed of material far less dense than typical comets, traveling at over 100,000 miles per hour through space should have destroyed it by now. Comets are fragile structures. They break apart from thermal stress when approaching the sun. They fragment from gravitational forces when passing near planets. They disintegrate from rotational stress when spinning too fast. A hollow object would be exponentially more vulnerable to all these forces. Yet 3I Atlas remains intact. It survived a direct hit from a coronal mass ejection in early October. Solar plasma traveling at millions of miles per hour slammed into the object. Most comets would show significant damage or complete disintegration. 3I Atlas showed increased outgassing, but structural integrity remained unchanged. The object has been experiencing significant outgassing as it approaches the Sun. All these stresses, thermal expansion, ice sublimation, internal pressure from heating, should compromise the structure. Instead, the object maintains cohesion. And now, observers are detecting multiple smaller objects around it. This raises the critical question that no one wants to ask publicly. Are these broken pieces that recently separated from the main body? Or are they companion objects that have been traveling together from another star system? If these are fragments, we would expect specific evidence. A debris trail stretching behind the main body. Progressive deterioration visible in sequential images. Signs of structural failure on the parent object. We're not seeing those indicators. The main body appears stable. The companion objects maintain consistent positions relative to 3I Atlas. If they're not fragments, then what are they? But the mysteries don't stop there. Let's talk about water release. 88 pounds per second. A study published in the astrophysical journal Letters reveals 3I Atlas is releasing water vapor at an extraordinary rate. The observation comes from NASA's Neil Gehrels Swift Space Telescope when the comet was approximately 3 astronomical units from the Sun. That's 3 times the distance between Earth and the Sun. Most comets don't begin releasing significant water until much closer to the Sun, typically around 1.5 astronomical units or less. At 3 astronomical units, solar heating should be insufficient to trigger this level of water sublimation. The numbers don't make sense. If 3I Atlas is hollow, that could explain the water release pattern. A hollow interior with large internal surface area would allow solar radiation penetrating through thin walls to heat ice deposits from multiple angles. This would create more efficient sublimation at greater distances from the Sun, but this requires a structure fundamentally different from natural comet formation. Natural comets are solid aggregations of ice and rock. Gravitational collapse during formation creates dense cores. There's no natural mechanism that produces large hollow cavities in kilometer-scale objects. Not in our solar system, not in any stellar formation process we understand. Here's where it gets strange. By this time, spacecraft positioned near Mars should be capturing detailed images that Earth-based telescopes cannot provide. 3I Atlas is currently behind the Sun, from our perspective. Mars orbiters, Mars rovers with upward-facing cameras. Any probe in that region should have optimal viewing angles. The data should exist. The question is whether the public will ever see those images. When 3I Atlas swings back into full view in the next few weeks, astronomers will have another chance to study it with a full array of instruments. Ground-based observatories, space telescopes, radar facilities. The technology exists to answer every question we're asking. But will the data be released? The questions are piling up faster than answers are arriving. What is causing the water release so far from the Sun? Are we looking at one object or multiple objects traveling together? What explains the green glow when spectroscopic data shows insufficient decarbon? Why does the object remain structurally intact despite conditions that should destroy it? If multiple objects are confirmed traveling with 3I Atlas, it would represent a major development in our understanding of interstellar visitors. Not just how material travels between star systems, but what kind of material can make that journey, and whether that material formed naturally or through other means. But here's what makes this story even more compelling. The high-resolution data that could answer these questions about 3I Atlas has not been made public. We're relying on amateur astronomers right now to piece together what's actually happening. Professional observatories have the images. Space agencies have the spectroscopic data. Military tracking systems certainly have trajectory information. The data exists, but the full picture isn't being shared. NASA has been notably quiet. ESA has released minimal information. Other major space agencies that routinely publish findings about comets have said almost nothing about 3I Atlas. This isn't normal protocol. When comet Neowise appeared in 2020, agencies released daily updates with high-resolution images. When Comet Leonard passed by in 2021, we got detailed spectroscopic analysis within weeks. For 3I Atlas, an interstellar visitor exhibiting unprecedented characteristics, we're getting silence. This pattern isn't new. Oumuamua in 2017, Borisov in 2019, now 3I Atlas in 2022. Each interstellar object that entered our solar system followed the same pattern: initial observations, brief media coverage, then institutional silence while amateur astronomers continue documenting anomalies. Does that sound familiar? Because we've seen the exact same pattern with unidentified aerial phenomena, military encounters, radar data, video footage. Then very little information actually reaches the public. Both stories involve the same institutional reluctance to share complete information. Both involve objects that challenge our understanding of physics and propulsion systems. The parallels are striking. UAP reports describe objects performing maneuvers that shouldn't be possible with known propulsion. 3I Atlas exhibits characteristics that shouldn't be possible for natural comets. UAP data gets classified or withheld from public release. 3I Atlas observations from major facilities remain unpublished. Both phenomena generate intense public interest. Both receive minimal official acknowledgement. If 3I Atlas is confirmed to be carrying multiple objects across interstellar space, that fundamentally changes the conversation. Not just about comets, about what's possible, about what might be traveling through our solar system, about whether we're actually alone. And then something impossible happened. Statistical analysis of interstellar object arrival rates doesn't support what we're observing. Avi Loeb addressed this directly in recent statements. There is a limited reservoir of rocky material per unit volume in interstellar space. Even if you package all available material into objects the size of 3I Atlas or larger, there simply aren't enough objects to deliver them randomly to our inner solar system once per decade. The probability of 3 interstellar visitors in 5 years, purely by chance, is extraordinarily low. Oumuamua in 2017, Borisov in 2019, 3I Atlas in 2022. If these are random natural objects, we're witnessing a statistical anomaly that challenges current models of interstellar object populations. Either our models are completely wrong about how much material exists between stars, or these aren't random arrivals. Could this be the catalyst that opens the floodgates? If amateur astronomers force the issue by continuing to document and publish findings that major institutions won't address, those institutions may have no choice but to release the data they're withholding. Public pressure worked before. It can work again. If that data confirms multiple objects, if it shows structural anomalies that can't be explained by natural formation, if it reveals characteristics consistent with artificial construction, the implications would be enormous. Not just for astronomy, for the entire conversation about what governments have known for decades. We're not saying 3I Atlas is definitely artificial. The scientific consensus still leans toward natural origins. But we've reached a point where even conservative scientists are asking uncomfortable questions. When spectroscopic data contradicts visual observations, when statistical probability doesn't support arrival rates, when structural integrity exceeds what natural materials should allow, those questions become necessary. The data reveals patterns that demand explanation. An object that shouldn't glow green is glowing green. An object that should have fragmented remains intact. Multiple companion objects appear where natural comet behavior wouldn't produce companions. Water release occurs at distances where it shouldn't occur. The timing of discovery coincides with increased public awareness of unexplained phenomena. Here's what we know with certainty. 3I Atlas entered our solar system from interstellar space. It exhibits characteristics that differ from known comets. Multiple observers using different equipment have detected companion objects. Major space agencies possess data they haven't released. Amateur astronomers are documenting findings that raise more questions than answers. What we don't know is more significant than what we do know. We don't know the object's true composition. We don't know why it remains structurally intact. We don't know what the companion objects are. We don't know why spectroscopic data contradicts visual observations. We don't know what spacecraft near Mars might have photographed. We don't know when or if complete data will be released. The urgency is temporal. 3I Atlas will reach perihelion, its closest approach to the Sun, in the coming weeks. After that, it will begin its journey back to interstellar space. This represents a limited window for observation. Once the object leaves our solar system, potentially in the next few months, we lose the opportunity to study it with Earth-based instruments. Any questions left unanswered now remain unanswered indefinitely. If the object is hollow, if it's carrying companion objects, if it exhibits any form of artificial structure, we need to know before it leaves. Not in 5 years when someone finally publishes a retrospective analysis. Not in 10 years when declassified data might emerge. Now, while telescopes can still observe it, while spacecraft can still photograph it, while we still have the chance. The implications extend beyond this single object. If 3I Atlas represents artificial technology traveling between star systems, it establishes proof of concept. It demonstrates that interstellar travel is not only possible, but occurring. It suggests that other objects we've classified as natural might warrant re-examination. Oumuamua's tumbling motion, Borisov's unexpected brightness fluctuations. Every anomaly we dismissed as natural variation becomes a potential indicator. This changes the framework for how we interpret future observations. Every new interstellar visitor will be scrutinized not just for scientific interest, but for signs of artificial origin. Every unusual characteristic becomes a potential marker. The conversation shifts from "are we alone?" to "what's traveling through our neighborhood and why?" That shift has already begun in some circles. Mainstream astronomers remain cautious, but younger researchers, those not invested in defending previous conclusions, are asking different questions. The data doesn't fit natural models. So either the models need revision, or we need to consider alternatives we've been reluctant to discuss publicly. The reluctance is understandable. Careers are built on peer-reviewed publications. Reputations are staked on defendable positions. Suggesting artificial origins without definitive proof invites ridicule. But at what point does the accumulation of anomalies outweigh the risk of speculation? At what point does refusing to consider alternative explanations become more damaging than exploring them? We might be at that point now. The data exists. The observations are documented. Multiple independent sources confirm the same findings. The question is whether institutions will acknowledge what amateur astronomers are reporting or continue maintaining silence until the object leaves our solar system and the opportunity passes. If 3I Atlas leaves without comprehensive study, without released data, without answers to the most basic questions about its composition and structure, that would represent a failure of scientific inquiry, not because we didn't have the tools to study it. We have the best telescopes ever built. Not because we didn't have the opportunity. The object passed through our inner solar system, but because institutions chose not to investigate thoroughly or share their findings. That failure would echo across decades. Every future interstellar visitor would be approached with the knowledge that we had a chance to understand these objects and chose not to take it. Every anomaly would carry the weight of unanswered questions from 3I Atlas. The precedent would be set. Observe from a distance. Document anomalies quietly. Don't pursue explanations that challenge existing frameworks. Is that the precedent we want to establish? The alternative is transparency. Release the high-resolution images. Publish the complete spectroscopic data. Share the trajectory calculations. Let the global scientific community analyze the findings openly. If the data supports natural origins, that conclusion will emerge from rigorous analysis. If the data suggests something else, that conclusion deserves consideration, regardless of how uncomfortable it makes traditional astronomers. Science advances by challenging assumptions, by testing hypotheses against evidence, by following data wherever it leads, even when it leads to conclusions we didn't anticipate. The discovery that Earth orbits the Sun, not the reverse, challenged fundamental assumptions. The realization that stars are other suns challenged our understanding of cosmic scale. The detection of exoplanets challenged models of planetary formation. Each paradigm shift began with observations that didn't fit existing models. Each required scientists to consider explanations they initially resisted. Each ultimately advanced human knowledge by forcing us to expand our conceptual frameworks. 3I Atlas might represent another such moment, or it might be an unusually interesting but ultimately natural comet. We won't know until the data gets analyzed comprehensively, and we can't analyze it comprehensively if major institutions won't release what they've observed. The clock is running. The object is approaching perihelion. After closest approach to the Sun, it will begin accelerating back toward interstellar space. Within months, it will be too distant for detailed observation. Within a year, it will be beyond the reach of even our most powerful telescopes. The window is closing. What happens in these next few weeks determines whether we seize this opportunity or let it pass, whether we demand transparency or accept silence, whether we pursue answers or live with questions. The choice, ultimately, rests with the institutions that control the data and the public that funds those institutions. If multiple objects are confirmed around 3I Atlas, if the green glow gets explained, if the water release pattern makes sense, if the structural integrity gets accounted for, then we'll have advanced our understanding of interstellar visitors significantly. If those questions remain unanswered because data stayed locked away, we'll have missed a chance that might not come again in our lifetimes. The universe is not required to present us with convenient opportunities to study interstellar objects. We've had 3 in 5 years. That's either extraordinary luck or something else entirely. Either way, treating these opportunities casually, as if we'll always have another chance, seems dangerously naive. 3I Atlas is here now, visible now, observable now, analyzable now. What we do with this moment determines what we learn, and what we learn determines how prepared we are when the next interstellar visitor arrives. Because if the statistical analysis is correct, if these aren't random arrivals, then there will be a next visitor, and we should probably figure out what we're looking at before that happens. If this video changed how you think about interstellar visitors, make sure you hit that like button and subscribe to this channel. We're tracking 3I Atlas in real time, and you won't want to miss what happens as it approaches perihelion in the coming weeks. Drop a comment with your theory. Are these natural fragments breaking off, or companion objects that have been traveling together since another star system? And share this video with anyone who thinks all comets are just ice and rock. After this, they'll never think that again.